boys and girls, so we're going to look at topographic maps. In the past, we've been looking at these plate boundaries, how they move around and create all these landforms. And so we're going to look at maps that show these landforms, though, in a two-dimensional aspect. So on the screen here, you can see towards the left, we've got a foam mountain. And then on the right side, we've got what looks like a bunch of little circles inside of each other. It says, has an E, has a W. So looking at those foam mountains, that's an actual 3D mountain there. Each of those layers there, it's kind of showing and building, creating this 3D form. The map on the right side, all those lines inside of each other, that is what a topographic map looks like. So some of you may have seen something similar to this if you've ever looked at a road map, maybe if you've gone camping, if you play, I'm sure some video games have some types of maps like that where you can kind of see where you're going or see where your enemies are. But these type of maps, though, they use in a lot of conventional sense. So if they need to build or construct things, they're going to look at a topographic map to see what the landforms look like. If you do go hiking or hunting or traveling in the wilderness, at least, and you need to know what the landform, if you need to know like where a river is or where the highest peak is, where a steep slope could be, then you would look at a topographic map. And then also in armed forces, any military type thing, they look at these maps to see what the area around them may look like whenever they're trying to do whatever military people do. But so these maps are more conventional than what you think, although I know many of you haven't actually looked at them yet. So we're going to go through and label this and just kind of piece it apart and see how to read these maps and what the map is telling us by just looking at it. So looking here at this map here, we've got, like I said, a two-dimensional version of that mountain. On the map, we have a W, an E. W is just representing that's the west side of that mountain. E is the east side of that mountain. On this mountain, we only have one peak. So if you look at this, the image on the left, a peak is where it goes up and comes back down. On this mountain, we only have one. It all goes up to a top part, which on this map, the X is the top. It all goes up to the top and then comes down. As we're looking at this, on these maps, each of these lines represent something. So each of those lines, though, they are called a contour line. So I'm going to write down these definitions at the bottom. You'll need to refer to them later. But each line is a contour line. And so that shows you the elevation. Now, I know that the 3D picture is a little small, but that top left picture, it does show you the elevation at each of those layers. And so if you look down at the very bottom, the very biggest layer, you'll see a tiny little 11,000 right in there. So that means that at that bottom layer, it is 11,000 feet above sea level. So on my map here, I'm going to label 11,000. Now the next layer says 11,005. So I'm going to write 11,500. So on and so forth until I get to the very top. And so once I get to the very top part of this, it is 13,500. And so I know that that is the top of this mountain because it is the smallest layer in the center. As you go up like that, the lines will not overlap ever, but as you go up, the elevation increases. And so on this map particularly, the top layer, the smallest circle, is going to be my highest elevation at 13,500. Now, each of these contour lines, like I said, each line represents the same elevation. So that means that this 11,000 here, anywhere on this map, if I trace this around the whole thing, that means that it's 11,000 there. This first line over here, that's 11,000. So it doesn't change at all. If you just find the elevation, find wherever it's printed, follow the line, it'll tell you whatever elevation is at that point. And so it stays the same. So think of it like if you were a little ant crawling around each of the lines, then you'll be able to tell what the elevation is if you stay on that same line. But if you traveled upwards, so if I move from 11,000 and I go to the next line, my elevation increases because the next line is at 11,500. And so in order to tell whatever that next interval would be, or what that next, elevation would be, you count by what's called the contour interval. So when you hear the word interval, just think of counting or changing by the same amount. So the contour interval is the change in elevation between contour lines. And so that means that on this map here, the difference between each line is actually going to be 500 feet. And so on this map, the contour interval, oh, that's an I, contour interval would be 500 feet. So that means that even if I didn't have all those lines labeled, I would know that I count by 500 each line. So we count upwards. Now, the other thing to take note on this map is how steep or how shallow the slopes may be. Okay, and so if something is steep, it's going to be, let's see, like something steep would be a sheer drop off like this. Okay, a cliff would be steep because I suddenly go from a high level and it drops down to a lower level very quickly. If something is gradual, think of it like a hill. All right, a gradual change is a slow change. That could be something like, well, I don't know, like a hill, a ditch. Anything like that would be a gradual change, meaning that the elevation changes slowly over time. So looking at my map here, the area where I have the steepest slope would be, let's see, so the steepest slope would be on the east side. So looking at this map, we can say that, I'll just put a square around it. We can say that this would be our steep area because those lines are closer together compared to some of the other ones. Now this map doesn't have them very, very close, but still. So a steep slope means that the lines are close together. So the lines will end up looking, they stack up on top of each other. Now, let's imagine I'm a little ant and I'm crawling around on this map. I would not want to climb up a very steep area. Maybe I'm just not wanting to exert that much energy. So you want to pick the gradual slope. A gradual slope on a topographic map is going to be when the lines are very far apart. So on this map, it's going to be on the west side. So the lines are far apart. That means that in that distance, the elevation is slowly changing, and so it's easier to climb, easier to go up, anything like that. Now the other feature that we have on this map, notice these V's over here. Compare those V's even to this, the above view. You can see it's this area that I'm talking about. So this, though, that's saying that something is carving out and something is creating this divot in the mountainside. And so these V's are created by weathering and erosion. And so water is flowing over that. It's a river. So water's flowing over that, and it's carrying this sediment downriver, carrying it to the ocean, to a lake, to a river, whatever is further below it. So the V shape equals a river or water. Sometimes it could be a stream, however technical you want to be, but the V shows the river or the water. Now, the one key feature we need to be able to decide and pick out is what direction the water is flowing. Remember, this is a 3D map, or not, it's a 3D image, although it's a, two-dimensional map. But on this thing, the V's will always point to wherever the water is coming from. They point upriver. So in this case, my water, I'm just putting a blue dot, but the water would be here, and it is flowing down the mountain off to whatever other place. And so as that water is moving over it, it's carrying sediment with it to deposit it further along. And so the V's, they always point to wherever the water came from. Now the only other key note to take from here is deciding whatever the highest elevation is. So if you were looking at the topographic map, yes, my highest line right here is 13.5, but Remember, it's a 3D thing. It doesn't just plateau, it doesn't just stop at the top. And so in this instance, in this map, the highest elevation is going to be, it's always one below whatever the next contour interval would be. And so this example would be 13,999. Because if I increase from 13.5, the next one would be 14,000. But since I don't have another complete line, then it is not 14,000 feet high.